So you just bought a new multimeter and you're not sure if you're using it right to test a power supply. Well, that's what we're here to do today. We have our power supply. This power supply is an older generation ATX power supply. The connectors it has on it that we are going to attempt to test are the 20-pin P1 connector, which there's one, the 4-pin 12-volt auxiliary connector, of which there's also one, the Berg connector, used for floppy drives, of which there are two, the 4-pin Molex connector, of which there are two, and the SATA connector, which is used for newer hard disks, of which there are also two. Something you might notice that's interesting about this SATA connector is it's actually another Molex connector. It's just an adapter. So we can test this Molex connector to at least ensure that there's voltage to here. We've also got our IEC to Edison cable, very standard. We'll test that as well. I've got a power strip here, which I like to use because it's got a switch on it, which means I can very quickly interrupt the power to this whole test very safely without needing to grab for things and unplug them. We have our meter. I'm going to be using this Fluke 376 True RMS clamp meter, because it's the one I'm familiar with. But there's also other options. There's this very affordable alternate meter. This one's almost $500. This one's under $100. Both meters have this dial on them, which allows you to set the mode that you want. This meter, being a little bit more robust, has less knob settings. It's a little counterintuitive, but what these more knob settings do is give you different levels of precision. So there's 5 DC voltage settings, whereas my meter, the other meter, only has one and only needs one. This meter will automatically range to the appropriate precision of what you're metering. And this one needs a little bit of help. So if you're using a meter like this and you're metering AC voltage, that would be this range right here as designated by the little sine wave and the V, and you're looking to check something in the hundreds of volts, say 120 volts, like a wall outlet in the United States, you'd set it to the hundreds of volts AC setting. And similarly, if you were going to test the outputs on an ATX power supply, such as this one, which is somewhere between 3 volts and 12 volts, you would set it to the tens of volts DC range, DC volts being that V and then the solid and the dashed line right there. The other things we need for this test is our pinout. What they do is it's a picture of the connector basically and a description of what each pin does or what you should expect the voltage range of each pin to be. Lastly, to test this ATX power supply, to signal to this power supply that it's turned on, we have to use a bent paper clip. This bent paper clip will be inserted in between pins 14, which is called PS on, and a common, of which there are many on this power supply. I'm going to use pin 15 common. Now in normal use in a PC, the motherboard or the power button would indicate this circuit closure, would tell the power supply to turn on. The next step, really the beginning step, is I think to test the power coming in. I could test this power strip, but instead I'm just going to test this IEC cable make sure that I'm getting something like 120 volts to it. So I'm going to turn my meter to volts AC. I'm going to stick the probes into the two upper slots, this lower center slot being the ground. And we can see on this meter that we are getting 121 volts, which is well within range. I'm going to unplug that, switch this power strip off, plug in this IEC connector to the power supply, and then turn it back on. There's a green light on the side of the power supply, which is lit up, and the fan is moving. So I believe that not only is power being received by this, but also that my little jumper trick here has worked in communicating to this power supply that it should be in on mode. So the next step will be to refer to my pinout. I'm going to start with the P1 connector and move my way along pin by pin, circuit by circuit, and then connector by connector until I'm all done. So according to my pinout, pin 1, which is this pin right here, should be, I'm going to set my meter to volts DC, and then pin 1 should be plus 3.3 volts, and pin 3 should be a common that I can use to test this circuit. So I'm touching my red lead to pin 1, trying to, and my black lead to pin 3, and you can see a nice stable 3.3 volts. I can continue to test here. My pin 2 should also be 3.3 volts, and it is. Pin 3 is a common. We tested its functionality already. Pin 4 should be a plus 5 volts DC. So I'm touching my red to the plus 5 volts. And on my meter we can see I've gotten 5.2 volts, which is pretty good. I'm going to continue on. Next we have a common, then another plus 5 volts, and that's working. Another common, touching pin 9 to the common, I'm getting 5 volts as well. And then pin 10 to common, should be getting 12 volts, I'm getting 11.2 volts. Which I think we're going to find as we continue to test this. So we've just tested pins 1 through 10 on this 20-pin P1 connector. Moving on to pin 11, should be 3.5 volts, and my nearest common to that is pin 13. Test that, and I see again 3.3 volts. Pin 12 should be a negative 12 volts. And I'm getting here a negative 11.5 volts. You can see the little negative off to the left there, indicating that we're seeing negative polarity in that instance. Pin 16 is a common. Pin 17 is a common. Pin 18 is plus 5 volts DC and is entirely missing off of this connector. Pin 19 is plus 5 volts DC, and I'm getting my usual 5.2. Pin 20 is also a 5 volts, and I'm getting 5.2 volts as well. So, we've established this connector is working. Let's move on now to our 12 volts DC auxiliary connector. We have 2 commons and 2 12 volts. I'm going to start by testing the top common and the top plus 12 volts DC, and I'm getting 11.3 volts. Oh, back to 11.2. So within expected tolerances. I'm now going to jump to the bottom, do the same thing. testing the common to plus 12 volts. I'm getting 11.2 as well. So this connector is good. Moving on now to our 4-pin Molex connector for peripherals, older IDE hard drives, and some extra accessory power for PCI cards. We have 2 commons to test, a plus 12 volts and a plus 5 volts. So the 2 center pins are the commons. I'll insert my black connector into one of those. And the kind of connector where you can actually insert the probe is such a relief. We don't have to hold them on. They actually can hold themselves in place, which is really nice. I'm going to touch my red lead to the what should be plus 12 volts, and we can see it's 11.2 again, that classic. I'm going to now jump my black lead to the other common, just to test both common connectors, just for the sake of thoroughness. And we're getting 5.2 volts here again. So this power supply is not exact, but is very consistent. All right, go ahead and move on to testing the Berg connector here, of which there are 2. You can see that these are actually really tiny, tiny probe holes. The pins that this connector would accept are very small. And after pushing really hard and disforming it, I can see that I'm getting 5.2 volts and 11.2 volts. So really had to press firmly in there to deform the plastic on these, and you can see that they got bent a little bit. The last connector that we could test on this power supply is the SATA. And these pins are so small, much like the Berg connector, that these probes are at least twice as wide as those pins. In preparing for this video, I tried metering pin by pin each of these, and I found it was very easy to short. That is, to connect the same probe to both a common and a voltage, which shorted the power supply out, made it go into a protection mode, and I thought I had bricked it. So I don't think it's safe for me to do that here, to take a working power supply and break it in the interest of trying to test it. I'll include a link on this as well, but there is a variety of accessory type probes that can be purchased. Should have much smaller probes, and that would be much better for testing both the Berg and the SATA connectors. As I'm afraid of testing this connector and possibly doing damage to the power supply, I will instead settle for testing these other 2 Molex connectors, making sure that power is at least getting to here. The other piece of equipment that I wish I had, that I wish I had grabbed for this project, is a tool called a set of helping hands. And they're basically 2 or more alligator clips attached to a heavy base that you can then clip a connector to or a cable to, and they will just hold something for you so that you can have both hands free to do your metering, or you can have a connector held in place and a wire held to it for soldering. They're great for solder work. They're great for testing equipment. Wish I had one of those. All right. Thank you so much for joining me.